I see CPLs for one stirrup here. All right, so this is our next chapter. This is graphing linear functions. So we're going to be graphing lines, and there's some rules that go with it. So we have some things to cover in the next couple pages. So take the notes you want. So remember this. This is an old thing. If you had an input, you subtract 80, and then you get an output. So if I put 130 in, I would subtract 80 from that, and I get 50 out. If I put 290 in, I'd subtract 80 from that. But then if you went backwards, if I had put 20 in, and I had originally subtracted that negative 80 from it, basically that would have come out to be 100, and so on and so forth. So remember, you can work these backwards as well. So if I was going from here, so if I was going from input to output, I was subtracting 80. If I went from output to input, I would add 80 to it. Okay. So a relation is like ordered pairs, x comma y, or 2 comma 3, or -7 comma 2, -2, or it could have been on a t-table where you had values here and values here. A function would be, a function is a special relation, so it's a special relation that does not have, excuse me, have the x values, and we call the x values in math the domain, repeating. Okay, so if you were to look at a list of things, or you look at all your x values at a bunch of points, none of the x values would repeat. That means it would be a special kind of relation called a function. Okay, so the domain are the x values. We call those sometimes the input. If you had a point, it would be, this would be the domain. Your point are the x values. Okay, and I don't have a y value there. The range are the y values. We also call that the output. So if we had some points, just fictitious points, the ranges are the y values. Okay, function versus non-function test. Okay, so the first one, we could write this as 2, 4, 4, 8, and 10, 20. None of the x values repeat. Okay, so yes, this is a function, this first one. This next one, we have 1 comma 20, and then 1 comma 8, and then 4 comma 4. Because the x values repeat, this is not a function. And then this next one here, this would be like saying 110, 210, 310, 410, and 510. So the y values repeat all day long here, but the x values don't. So yes, this is a function because the x values don't repeat. And then looking at this, okay, I have the point 1 comma 2, 2 comma 2, 3 comma 0, 1 comma 5. Being those x values repeat, this is not a function. Hope you guys are doing well today. All right, so testing if it's a function. There's something called the vertical line test. If I can draw a vertical line and it crosses the function twice, that means it won't be a function. Okay? If I had plotted these points, we would have the same x value on each of them for those particular points, and that exists anywhere in here. So if your x values repeat, it won't be. So the vertical line test. But again, vertical line test, it's going to cross twice, so this is not a function. But this next one is, because even though it's a v, if I draw the vertical line test, it's only going to cross the graph one time. So yes, function. Okay, function names. So we have y equals 2x plus 3. A function? Yes. Yes, it's a function because if I created a t-table, if I plugged in x values here, I'd get certain y values out here. If I repeated an x value, it would give me the same y value. So that means that it's the same point. So yes, this is a function. Okay. Then we make it look like this. We change y to f at x. This stands for f at x, or you could say f of x. They both mean the exact same thing on both. So when we have functional notation, if we have, this is an input. So if we wanted to find what f at 6 is, I'm going to take that and I'm going to plug it in right there. So I'm going to get f at 6 is equal to 2. There was an x right there, but I'm going to plug a 6 in instead. So that's going to give me 12 plus 3, which gives me 15. So this would have yielded me the point 6 comma 15. If I have the value outside, that means we need to solve it. So I'm going to plug this in for f at x. I'm going to plug it in right there. So I'm going to get 6 equals 2x plus 3. Then I'd subtract 3 from both sides, so that's 3 equals 2x. Divide by 2. So I'd get an x value of 3 over 2. And again, leave it as a reduced fraction. Okay. Make sure you have these down when we work these two. Okay. All right, so if it's f, we're going to deal with the f. If it's a g, we're dealing with the g. So f at 1 means I'm going to go 3 times 1 minus 2, which is negative 3 minus 2, which is negative 5. G at 1 is going to be 10 times 1 plus 2, which is 10 plus 2, which is 12. This one's going to be negative 3 times 0 minus 2, so that's 0 minus 2, which is negative 2. G at 0 is going to be 10 times 0 plus 2, which is 0 plus 2, which gives me 2. F at negative 1, that's going to give me negative 3 times negative 1 minus 2, which is 3 minus 2, which is 1. G at negative 1, I'm going to go 10 times negative 1 plus 2. So that's going to give me 10 plus 2, which is negative 8. Then we switch. Now I'm going to plug that negative 8 in right there. So add 2. So that's negative 6 equals negative 3x. Divide each side by negative 3. So x is equal to 2. And same with this one. We're going to plug this in here. So 32 is equal to 10x plus 2. Subtract 2, subtract 2. So that's 30 equals 10x. Divide by 10. So I find that x is equal to 3 over 10, which is just 3. So sometimes you plug it in for where the y value would be, or the function would be, g at or f at, or whatever letter at. Okay, analyze the graph. Okay, so we're going to talk about the domain. The domain here is going to be time. So our domain here, there's a 0 down there, is going to go from hard bracket 0, because we have a point there, to a hard bracket 60. The range is going to be beats per minute. So again, it's a point there. So it looks like hard bracket 70. This is not my highest point. This is actually my highest point here. So that's going to be to 150. And that point is indeed on the graph. So that's a hard graph. When is the interval increasing? So I'm going to highlight this. Increasing means it's going to the right, going upright. So those are the reasons it's increasing. It's decreasing when it's going down to the right. Okay? And we can list those as kind of a set. We can say from 0 to 20. So from 0 to 20 hard bracket. And then from, 0 to, that's not 20, that's 15. Excuse me, 15. And then that's a 15. And then it's going from 20 to 35. And then it's also increasing from, that's to 30. Boy, oops, I skipped over. Go back. That's to, that's to 30. Then it's going from 35 to 60. So you're telling in the x direction where it would be increasing. It would be decreasing at 15 to 20. And then 30, 35. And then last one is 50 to 60. And you know what? I'm going to make all of these rounded brackets because right at that exact point, it's doing something different. So these will be rounded brackets of the increasing and decreasing. So the maximum value of our function is the highest y value. So the maximum is going to be at 160. And the minimum value is the lowest point on the graph. So we have it here. And that looks like a little bit above it. And that's a little above it. So this is going to be still a y value. But it's my lowest y value, which in this case it looks like it's going to be 70. Okay. And we're going to take a look at the next graph and see where that goes as well. Okay, so remember the domain. In this case, it's going to be time, which is the x value. And so our time is going to start at 0 and go to 12. And notice that's an open dot at the 12. So it's a square bracket here because it's a solid dot, and it's a soft bracket there because it's an open dot. The range, we're going to go from, in the y value, which is, this is the depth. So our lowest value is going to be 0 in the y direction all the way up to 24. So it's a round bracket at the 0 because it was an open dot, and a hard bracket at the 24. Where is this increasing? So increasing, it's going to be here, it's increasing, and that's the only place it's increasing. So we can go ahead and label that. We can say that it's increasing from 6 to 9, both soft brackets. Where is it decreasing? Let's use a different color. It's decreasing here, and here, and here. Okay, so it's going to decrease, and we're going to put each interval in there. So we're going to go, it's decreasing from rounded bracket 0 to 6, 9 to 11.5, and then 11.5 to 12. Soft brackets on each of those. The maximum value is going to be the highest y value. Okay, so let's look where the highest y value would be. Oops, it's up here. It's at 24. And my minimum value is down here. It's going to be about 12. Or excuse me, about 0. Okay. Notice I didn't have the squiggly abouts for the 24 because there's a solid dot, but there's an open dot here. So we're about 0. Okay. That's all we have. Make sure you take a look at the worksheet and take care of one another. The homework on this will be the page 43 and 44. 43, 44. And let's have us look at doing the odds. Have a great day, everybody. Take care of one another. Bye-bye.